Okay, I had a question.
Yeah,
On
go
our
ahead.
okay, on our quiz, the I had a question in reference to the one of the questions was I believe it was a referencing environment. I think it said where I'm in class. Shut the door.
Okay, reference environment. Okay,
Well,
then
it said a complete set of binding active a complete set of bindings active at certain points in a program. And I thought that was a referencing environment. And that's what I put in there, but it gave me that I was wrong. And I thought it was correct.
reference environment. Okay, the issue is okay. Say your answer, for example, reference environment, right?
Yeah.
So, for example, you write this reference environment. Okay, let me explain it. Okay, environment. So if you put a S, no S. For example, if I write the correct answer as environment, but no S, but you put an S, for example, right? Assuming that you know the answer, but it will get you the wrong scoring, right? So in this case, please take a picture on your answer and send me by email. I may manually modify it.
Okay. I don't think
Okay.
it shows the I don't think it gives it doesn't show us like our answer.
It doesn't show you an answer.
No, it just shows us that we got it wrong.
You get it wrong, but if you believe that you are correct,
Just email you. Okay.
just email me. If you believe you are correct, and I may give you an answer, okay, no, okay, I may give you an answer, no, your answer is wrong, right?
Right.
I may correct your point, say originally 0 point, now I change it to 20, maybe. So may end up with these two options. You know what I'm saying?
Okay. So if
So for
we
example, if you write a reference, but you say refer, right? For example, you put two R in there, right? For some reason, I may still give you 20. Is that okay?
gotcha.
No matter what
Okay.
you write, okay? But if you actually give me, say, if you actually write me a request environment, sorry, that one I could probably give you little, okay?
Okay. So I have a question for you. So like
Yes.
let's say for the ones that we just don't know and we actually get them wrong, is it a way can we also email you and say, hey, I got this wrong and I know I got it wrong and I'm okay with that? Can you tell me what it is? Because I've watched the
Yeah,
videos and
sure,
read and I
sure.
just don't know.
Yeah, sure.
Okay.
Yes.
Okay, thank you.
The reason why I do not put it in auto response because I give you two attempts, right?
Right.
So if I give you the standard answer, then the second time you just copy, right? So it makes no sense.
Okay.
So
I
so
don't
at this
think any
moment,
of the instructors do though. They never
yeah,
give us the answer.
yeah.
Yeah.
So I cannot give you the answer because we have two attempt policy.
Okay.
Unless all of you don't like the two attempt policy, then we may
No, I
change.
love that.
Yeah. Okay.
Don't change that.
Okay. Any other question?
Thank you.
Any other question? You can just go ahead if you have any other question. Okay. So Joseph, you have question?
Yeah, sorry, I was finding my
Yeah,
mute
go
button.
ahead. Go ahead. Yeah.
My question is on our week 4 code, the tower question.
Week 4 tower question. Yes. One moment.
It's
Okay.
question 4.
Yeah, question 4. I know. It's question 4. I know.
Yeah. My question is just how would we go about gathering extra spaces? That's where I'm just getting hung up on is I can get the tower to print, but it all
Yes.
seems to be printing with the same amount of spaces between all the points and stars.
Okay. So this one is to test your capability to do modeling. Okay. So let's look at the tower 1. Tower 1 apparently is this. Okay. So basically, this one I would say 1 1. Okay. 1 1 1 depth 1 depth. Okay. And then starts at 2 times, right? 2 times. Second one, so you finish this one. Second one, you do. So this one is the first iteration. You print this one, right? Second iteration here, you have 2 space. So suppose left 1 space, here 2 space. So this is the second iteration. So you still print this, right? And you put this here, right? Is that okay? But if you are 1 right here, you don't have space. 1, if you are tower 1, you don't have space. But tower 2 here, you have 1 space.
Right.
Right? So this space calculation should be your minus 1. Right?
Okay.
So let's assume that we continue to move on to tower 3. Okay. So we move on to tower 3. So here we have this one, right? This, right? Okay. Here, that is, right? And here, like this. Okay. Okay. Let's look at the space right here. Space right here up to this one, it should be 0. This one, it should be 1, 1, 1, 1 space. Here, this one, it will be 2, 2, 2. So the iteration is, say, here is level 1, level 2, level 3, right?
Mm-hmm.
Or you can use a 0, 1, 2. Let's use 0, 1, 2 because we usually for I equals 0, I less than n, right? So this one should be what? 2 minus 2, right? This one is actually, I'm sorry. This one is 2 minus 2. This one is 2 minus 1. This one is, I'm sorry, this one is 2 minus 2. This one is 2 minus 0. Is okay?
Yep.
So your loop index 0, here you end up with 2 minus 0 space. Here loop index I equals 1. Here you actually have 2 minus 1 space. Is okay?
Yep.
So same thing here. Same thing here. You also have 1, 1, 1 space. 1, 1, 1 space here. And here you have 2, 2, 2 space. 2, 2, 2 space here. So we can parameterize like that.
Okay.
Got it?
Yep. I think so.
And here you have 0, 0, 0 over here.
Right.
Okay. And tower 4 similar. I'm sorry. Is that okay?
Yeah. Yeah.
So this one is to test your capability to do abstraction and model it with parameters. Okay.
Okay.
Okay. Any more questions?
That's all I had.
Oh, you have? How about Margaret? You have question? Hello, hear me? How about Monica? You hear me?
Yeah, can you hear me?
Yeah, anybody has questions, just go ahead. Yeah.
I have a question about the project 1 sorting algorithms.
Project 1 sorting algorithm, yes. And then?
I'm stuck with the 100,000 elements. It works with the merge and quick sorts, but the bubble sort, insertion and selection sort, they like keep running and never stops.
Then you may have algorithm wrong.
But it works with the merge and quick.
Is
it possible it can take like an hour? Because I had it running.
No, you won't take an hour. No, it won't take an hour. Okay, it won't take an hour. So. But
it works with all the way up to 10,000 elements. But if I try to 100,000,
it shouldn't have that problem. Okay, because everybody measure the time. If it has a problem, okay, the same problem I finish it before I make it as a homework. You know what I'm saying? The same problem I try it. I do have a solution. That's what I should say. I do have a solution. So I finish all the sorting algorithm. So if it's not doable, we don't make it as a homework. So if your program cannot finish, there's definitely something wrong. Is that okay? There's definitely something wrong. But this one, okay, instead of talking about it, okay, let's actually do this. Okay, let's do this. Let's do this, okay? Let me bring up my Visual Studio Code, okay? So here, this one, well, it is a project, but it's really want you to practice your programming skill, okay?
Mm-hmm.
So what we want you to do really is that you are okay to refer to some other people's sorting algorithm, okay? But try not to copy. I do not encourage copying of the algorithms, okay? I do not encourage copying of the algorithm, but I do want you to read or study other people's sorting algorithm. If you really don't know how to do it.
Yeah,
okay?
but what really makes me confused by why is it working with the 10,000 and not with the 100,000?
Then
that-
it must have bug.
Okay.
It must have bug somewhere. Okay, it must have a bug somewhere. So where it went wrong, I don't know, because I do not see your call,
Okay.
and it is your responsibility to figure out what it is. Okay, it is your responsibility to figure out which one, because I cannot debug for everybody. There are so many people. But what we have here is that, okay, the whole homework's main purpose is we do want you to actually exercise some sorting. So let's assume that we do insertion sort. Okay, insertion sort. Okay. So let's assume that we do insertion sort. Okay, I'm sorry. Here, this one should be insertion sort.py. Okay, I forget the py. Okay, so what you want to do is like, okay, let's assume that we actually try to create some random sensor. So import, okay, random, okay, and then we want to create a sample. So let's do a array. Okay, a array will be running random that rand integer. Okay, run this integer, and for I, okay, in range. Okay, so let's assume that here this one we want to run. You say 10,000,
100,000.
100,000. That is
Right, the
Right.
100,000 one she's saying.
yeah. This is the 100,000, and we want to use a 1,000, but repeat is okay, right? So we put the n over here, right? So this one will give us the samples. So let's try this one. Okay, try this A. Okay, so here I don't try this many. Let me try 100 first, because the printing would take a long time. Okay, printing would take a long time. So let's actually run this one. Okay, let's see something wrong. Okay, so require position missing one, require position. Okay, I think it may be starting from 0 to this. Okay. So let me actually say this one more time, okay? Because there are so many functions, so many language, sometimes I just miss. Okay, so here let me change back to 100,000 samples like this, okay? So here let's run it, okay? So you get some number, okay? Okay, but there, before you go to here, let's go back to here. We are going to do sorting, okay? So this one is actually just call this one, say, okay, before sorting. Okay, before sorting we get this. Okay, and then we will copy, okay, and paste, copy and paste, and this one would be after sorting. Okay, so in the middle we can do sorting. So let's do sort. Okay, let's actually call it I sort. Okay, insertion sort. Okay, so insertion sort A. Okay, and right here we are going to create. Okay, let's put it over here. Okay, so let's actually define a sort called I sort, insertion sort. This one does actually have a sequence, so it's SEQ. Okay, sequence. So we get a sequence. We are going to do insertion sort. So while you practice, okay, you must remember the algorithm. So insertion sort is every time we started from here. Okay, we started here. We have starting here. Okay, this one is the sorted location. Okay, sorted. So here we would have a number. This number would be to be insert location. Okay, so that's the first round. Second round, if we finish the first sorting, okay, we will have two elements, and then to be sold in location will be here. Okay, so you keep doing until the last one to be insert location will go to this location. Okay, so this one give us the outer loop. Okay, so here we will do for to be insert location. Okay, so to be insert location, the I will be in range. Okay, in range of starting from 1. Okay, to the last element. So it's the length of your SEQ. Okay, this one is the I is the to be insert location. Okay, I is the to be inserted location. So when you try to study other people's algorithm, you must remember what is the key idea of it. Okay, so here let's assume that we have 3, 5, 2, 1, 4. Okay, we want to solve it. So the first one to be insert location is this one. Okay, and it's in place. So first sorting, we will pass it. So we have 3 and 5. So first pass this one, original sorted area is here. We insert it to here. It become 3, 5. So 3, 5 is finished. Then the next one to be insert location will be 2. Okay, and we'll start to compare it. If this one bigger, we are going to ship it to here. Okay, bigger than it, it will start to ship to here, and then we'll put it into a location. Either is actually to the end of the array, or if there is a one that is smaller than it, then we'll put it over there. Right? That's the algorithm for insertion sort. So the whole idea is that you not only need to know how it works. You can copy, but I do not encourage copy. I want you to really remember the whole algorithm here. Okay, so later when you need to develop the insertion, so you can still do it. So the idea is that we starting from the to be insert location to the end of the array. So that's starting from here. So the first, okay, you should have a 4. Okay, J is to be insert location. Okay, it will be in range. In range what? In range you started from your I. Okay, your I location is the to be insert to be. You will start from I minus 1. That's the one you are going to compare. Okay, that's the one you are going to compare. So your to be insert location say initially you are. Let's assume that we have 3, 5. These are sorted. And now you are 2, okay? 2. So this one, J starting from 1, okay? Your I is this one, I is 2, okay? I is 2, J starting from 1. You down converting down to 0, and 0 is included. So you will go down to -1, and every time you decrease by 1, that's your value, okay? So at this moment, we don't know what it is. So that's actually print out the I, okay, for testing purpose, okay, for testing purpose. Print out I and J, okay, before we go further, okay, before we go further. So this one, we will have A, okay, A sequence. So here, let's jump, move down to only 5, okay, 5 elements. Make it easier, okay, and we will print out I and J value and see how it works, okay. So this one will give you the pair, okay. So basically, go from 1 0 2 1, okay, 2 2 1 2 0 2 3 2 3 1, okay, and then 3, okay, something like that, okay. So you go down like this, okay, you go down like this, but this may not be what we want to do, okay. So we will do this, okay. We'll use a while loop, okay. So that's had the J value starting from I minus 1, okay. J value by minus 1. So while J, okay, greater equal to 0, we end, okay, and actually what? And actually your this one sequence of the J value is actually greater or equal to greater than your sequence of the I's value, okay. While you're doing this, you will do J decrease, okay. You do J decrease. J decrease will decrease by 1, okay. So this for loop we are going to modify from the previous for loop version to here. Is that okay?
Yeah.
Okay, we are going to modify it to here, okay. So now that's actually look at this, okay, look at this. We did not ship yet, okay. So here we do have 1 2, okay, this is only here is out of order, and you would just do that, okay. Let's try one more time. Okay, so this one I think this one would be moved, okay. This one would be moved, okay. So something like that. That actually just try one more time, okay. Now this time let me change it to 10, okay. okay, it will show us how many shifting needed. Okay, anyway, let's do that. Okay, it will keep shifting. So when you finish the shifting, okay, okay, this portion, what we would do is your sequence of the j, okay, plus 1 will be equals your sequence of the j. Okay, every time you are going to shift the number by 1. Okay, you're going to shift the number by 1. Okay, because you have, say, you have 3, 5, and 2, and you are going to shift your 5 to here and shift to here. Okay, until here it has a right location. Okay. But because we with overshifting, when j equals 0, we'll actually shift one more, and you become -1. So right here, up to this one, you should actually do j, okay, will be plus equals 1, and you put your sequence of the j, okay, with your sequence of the I, okay, and this one you should be able to finish your insertion sort. Okay, so let's actually try this 10 element sorting. Okay, is that okay? Wait, some value are missing. Okay, I may make some mistake. Okay, I may make some mistake. So here let me use this one. Let's see, sequence J. Okay, you do shifting. J greater equal 0, okay, J decrease, J starting from I -1, okay, if J greater equal than that, you do shifting, okay, you will shift the data, okay. So this one, you should shift to the left, okay, and at the very end, your J, okay, here you don't have J, okay, here you don't have a J. So you will, your J decrease, okay, your J decrease. So at the very end, your J will use your I's value. Okay, I'm sorry. Here, this one, we would do this. Okay, your I will be overridden. So here, okay, here you should be say X. Okay, you should use X of I because your J, your sequence I may be changed. Okay, so this one you should put your X. Okay, and here we actually put the X. Okay, instead of using the sequence I, because sequence I, the shifted the data would override. Okay, this one give us the shifted insertion sort result. So the basic idea is that you need to try this. Okay, try to come out. You can refer to some other design, but try to remember the core computing idea and try it. Okay, so this time that actually, I'm sorry. This time that let's try the one you say. Let's go with this much. Okay, 10,000 samples, 100,000 samples. It will take a while, and that's what we want to do. Okay. Wait, let me see. Okay, did I require the 10,000 or 100,000?
100,000, I think.
Yeah. Let me check. Okay, let me check. A moment. Okay. So we want to have 5 data points for each sorted. So it started from 10 and then
Yeah,
100,000,
10,000, and 100,000.
Okay. Yeah, that's okay. If it doesn't stop, means that it actually takes longer time. Okay, by example, it is doable because I finished every single one. So it just take longer time. Is that okay? You need to measure the time, it just take longer time.
Okay.
But make sure your algorithm is correct. To make sure that your algorithm is correct, you can use a 5 or 10, especially 10 or 15, to test the algorithm correctly. Okay. And if it's still running, that means it takes longer time. That's it. Okay. That take longer time. Okay, we may wait for this one. Any more question?
No. Thank you.
Okay, let's see. Okay, how about let me see. Whoever still have question?
Hello, Professor. I have a question.
Yes, go ahead.
For the volume JSON to download on my computer, should I follow the same what you said for the NumPy and the Spicy, like the same way to download it on my computer?
NumPy, SciPy, okay?
Yeah, but I already downloaded, but I need now volume and GE JSON.
The SciPy, what I actually really suggest is you do install, but you do copy this portion, pip install this portion, copy, and then pass to your break window. So the so-called break window is you do window R, okay?
Okay, I did it.
And then you just do this. I'm sorry. You just do copy this thing, okay, and put it here and hit return. You install. Is that okay?
Okay.
That's it. All you need to do. So what you really need to have is this one. It'll give you the complete package. So what you should do is SciPy, say SciPy, and you type installation, okay, and you should go to here and you say install SciPy, okay, here web page, and right here don't include the Python dash and no, just pip install this portion.
Yeah.
You will install for you NumPy, SciPy, MapReduce, IPython, Jupyter, Pandas, SymPy, and Nodes. The whole package you need. Yeah.
And in order for the project term.
So in case for some reason NumPy, SciPy, whatever P doesn't work for you, right? Okay. In case those are different things just doesn't for you, you can still use this one, Excel. I accept it. Okay, so you calculate the time requirement. So you just come back and fill in your X and Y, whatever X and Y you want to have. Okay.
Okay.
You, in case that you don't get it and they say, okay, case 1, 2, 3, okay, you should be 10, 20 or whatever, right? So whatever I come out with the number and then 2, 4, okay, I just roughly do it, okay. And these are different numbers. So you can still use Excel and insert, okay, insert a chart, okay. In case that you finish the program, but you don't know how your installation just don't go through, you can still use Excel and take the picture for me. I accept it, okay. Or you don't have Excel, you don't have the money to pay for it, that's still okay. You go to your Google Sheet, okay, Google Sheet, and you try to use it here, acceptable. Is that okay?
Okay, thank you.
But
yes. My another question is for the project term. I choose it to do it like a I don't know if I'm pronouncing. It's a GE JSON and the volume. This is the library from the Python. Should I the same way download it on my computer? The same way, like you showed me now with this
GeoPython, you have to find out, okay? GeoPython, whatever Python package you may want to do, say GeoJSON JSON on Python, okay? This one, okay, you will have the Py install, okay? It will show you pip install GeoJSON, yes. Something like that. Yeah, you can copy and install. Yeah. But sometimes you download, but the tool may not be perfect. You have to study. You know what I'm saying? You have to study. So the whole project, the whole purpose is this language is so-called structure and interpretation of computer program, right? Computer program. Okay, so what we want to learn is here you have a, say, Java program. You compile it to some executable code, okay? and you set up the grammar, whatever, and then you convert it to here, okay? So we are focused on the interpretation portion, right? So it's a conversion of something is acceptable. So now let's assume that, okay, let's assume that you are super interested on the so-called GeoJSON, okay? So you may have a Google map, right? Google map. And here you may take a language of say here you say 1H3, okay, B 2B3, okay, C 3C3, okay, and then you go into some of the program you write, okay, that's the interpreter or something, and it show up the location A, B, C on here. It's acceptable like that, okay? It's a translation of some input language to the destination language. It can be graphical. That's actually okay.
Okay, I got it.
Does that make sense?
Yes, it makes sense. Thank you very much.
So in this case, say we get the address of all the students in the class, and this whole class is similar location, say in San Francisco City, and we just plot everybody's location in that San Francisco City using your program to do that. Is that okay?
Okay. Okay, thank you.
And how to post it, that's your job, right?
Mhm.
How to post it, that's your job. Yes.
Yeah, okay.
As long as you present some sort of interpretation, we are happy. Okay, we are happy to accept project like that. Okay.
Okay.
Any more question?
No, thank you.
Okay, anybody has any more question?
I do. I want to piggyback on the project. So,
Yes.
and I know I asked before. So, so you're pretty much saying is it's up to us to choose some type of data that we process. We create an interpreter or compiler, which that seems extreme to me to be able to do, but I guess we can. If you say we can, so we can do it. And it's we create some type of translation system to
Yes.
print out the data in a different form.
In
So
a different form. So
okay.
So a very simple one. Okay. Very simple one is this chatbot example. Okay. Chatbot example is okay. If you really don't know how, you say that you think that okay, my technical background is not that great, but I do want you to say okay, I need $1 million. You need to write some program that is, and it give me some answer. Okay, and Chomsky chatbot it responds. So basically, this one is you have a program, question come in, provide answer. That's some sort of translation actually. You know what I'm saying? Does that make sense?
Right, or it's at least some type of response.
There is some type of response, yes. So here I say, okay, I need a write, okay, whatever, and issue, okay, whatever. This one may or may not make sense. Okay, that's one translation. Let's look at another one. Another one is this Google, right? It's Google. So let's look at this Google. Yes, it's also a translation. So like here, like okay, Super Lotto in California, right? So it's actually okay, Super Lotto in California. Okay, so let's look at this one. You give the language, right? Super Lotto, okay, and then you do some parsing. Okay, the information, whatever passing, they pass to Google website, calculate the most related data, and then ship back to you in HTML format, right? That's also some translation.
Oh, that's great.
So such engine is also something. What we want you to do is like analyze the input that people provide and do something. So let's look at another example. Okay, look at another example. So here, some people type in coughing. Okay, coughing. Again, loss of the smell, right? And then boom, call back. Okay, you got COVID-19, right? That's also another diagnosis system. And you provide the input, but your program do translation. Okay, and then maybe you come back. Okay, cancer, you are dead. Okay, sorry.
You was like, okay, so I have okay, so what about this? Like, if someone puts in most popular celebrity or something like that, and then you post or I don't know,
Yeah,
and then
yeah, that's actually okay. So that's actually just for fun. Okay, just for fun. Okay. So here that's actually you enter Bill Gates. Okay.
uh-huh.
And then you return 1 trillion. That's okay. A Tom Cruise. Okay. And you return 1 billion. That's actually okay. Wait, that's actually just a translation system. And how
Okay.
you do the evaluation system, that's what your program should do.
Okay, gotcha. So if I was to find the funniest memes for certain words or certain phrases or something like that, or the best Twitter
Translation,
okay.
keep the word translation.
Okay.
Right? You want to say?
Okay.
So
Yeah.
so if you are so good, okay, if you are so good in Chinese and you actually you type in Bill Gates, right?
Mm-hmm.
You automatically transfer to the translator, okay?
Yeah.
That's okay. That's actually also translation system.
Mm-hmm. Okay.
We want you to analyze the text that you input, provide
Okay.
some output that related to the input, but must provide some value. So this is a so-called what? This is a so-called current term of the replay system.
Okay.
Read, evaluate, print, and look back system.
Loop back. Okay,
Yeah,
gotcha.
that's the whole idea we try to teach you and want you to create some sort of environment that can provide people service.
This is so exciting now.
That's our goal, right? We don't want to teach
Yeah.
you a fossil language that nobody use. You know what I'm saying?
Yeah.
Okay. So the
Yes,
key
sir.
idea is that this course for programming language, we really want you to be able to use the knowledge to the web searching, to evaluation system, to some sort of question and answer, auto answering machine system. Is that okay?
Okay.
Yeah.
Okay. Yeah, I'm
if
getting
you
like
say,
all type of ideas now.
Yeah.
Like, oh gosh,
so
yeah.
if you are so good that you can translate C++ compiler, that's also acceptable. You know what I'm saying?
Wow.
If you are able to do that, it's still acceptable. I welcome it. You know what I
Okay.
say? But as easy as a search engine front end, that's actually okay.
Okay, so would this not work if I, because this may not be a translation per se. Like if I was to do a project where we search for the cheapest prices, it's not really, if we put in boots or certain name boots or something like that, and we find the cheapest price that's online currently, is that not a translation of,
That's
not
okay.
really a
Okay. So
translation?
that's called so-called EGG, right?
Oh, okay.
Okay, and you show a boots whatever. Wait, I have no. It's not EGG. It's UCG. Wait, what's the boots name? Wait, my wife keep buying it.
Manolic blonde. I don't know any
I forget the name of the brand. I'm sorry.
Manolic blonic, or I don't.
I don't know.
You can do UGG boots because I mean, right now it's really cold in Chicago, so.
Boots. Okay. I really don't know what's the brand. Yeah, it's UGG. I'm sorry. I'm really sorry. Yeah. And you try to compare the price and give it. That's also a translation system.
Great, awesome. Oh, I would love to do that because I was thinking about doing that for myself.
So basically, we are doing language translation. You kind of provide us some sort of service to analyze the input stream. We will be happy. We'll be happy.
Okay, so we're scraping the web and we're comparing data, and then we're printing out what's the
So this one is so-called information retrieval.
Okay,
let's look at it in what more academic term, right? It's actually called information retrieval system. You try to retrieve your information online based on your input, and do deep mining, data mining to get the right data and ship valuable data to people. That's acceptable. You know what I'm saying?
Yes.
The whole idea is that you come to here to take this course, right?
Yes.
You are going to learn something, and that's something you need to put into a project.
That makes sense to me.
But do not include something that's not related to this course, then that's
Okay.
not what we want, right?
Yes, sir.
Okay, that's a totally irrelevant to the course, then that's not the project idea we want to have. The project idea we actually accept is the one that we actually teach, okay? It's the one that we teach. Anything related to this schedule, okay, will be acceptable. You know what I'm saying? You apply the knowledge that you learned from this course, you put it into the term project that actually will be acceptable. And
Okay.
the three example, Geo, JSON, or whatever interpreter for scheme, or that's those three just suggested list, not required list. Okay.
Yes. Thank you.
So three projects. We have three projects. Okay. Three projects. We do have three projects. Project number one, performance measurement, that compare file sorting. This one want you to review your Python knowledge. Okay. Second one, recursion on evaluation tree. This one want you to really work on the interpretation structure. Okay. Last one, we got these two ideas. We put it into a term project. Apply your knowledge you have to some real world application project, and it better to be something that you can present to your future employer. You know what I'm saying? Hello?
Yes.
Yeah.
Mm-hmm.
That's the purpose, right? You want to make the project be so attractive that your future employer look at it. Oh, okay, this is the person that we would like to have. Okay, this is the right person we want to hire. That's the purpose. Okay.
Yeah.
Okay. Any more questions? Okay, you can think about some more questions. Okay, so if no student has question, I'll stand by for at least 15 minutes. Okay, 15. Okay, and if nobody jump in, we will be dismissed. Is that okay?
Yes, this has been such an awesome session as usual. So thank you, Professor.
Yeah, no problem. You are welcome. Okay. So for me right now, okay, now let me actually look at browser. So I'm still recording the weekly session. I finished the week 8 already. So if you look at the week 8 video already there, okay. But all of the slices, actually I finished it, okay. You know, I got a very short time to prepare these different chapters of material, but I do finish all of the PowerPoint slices for each week, okay. But at this moment, I just do pre-recorded session up to week 8, okay. And I'm working on the week 9 right now, okay. I'm actually working on the week 9, and I try to finish with recording for each of the chapter week by week. So in the week 9, I also try to teach this scheme language, okay. So I'm working on that as well. Okay, so here I do the pre-recorded session, okay, chapter by chapter according to the table that you have in the syllabus, okay, including here the syllabus, okay. I do one by one, okay, and I'm trying to do that at this moment. I'm trying to do that. I'm working on the chapter 9, in the middle of chapter 9. So each chapter, all the slices I finished already. I'll just do coding, recording for it. Okay. Any more question?
You know what? Where are the slides? Because I haven't seen the slides, but I do watch the recordings, which I appreciate as well.
Mm-hmm. Any question in the lecture, or you need me to explain something in the lecture? That's also okay. This office hour is not just for homework, right? If you do have question about a lecture, it's also okay. But a lecture, we try to provide you the right view for programming language, okay? The right view for programming language course. We are teaching you the mechanism, okay? Mechanism. So the course is called programming language, okay? Pragmatic, okay? Original name is pragmatics. It's teaching you some sort of mechanism, okay? So compared to say you come to the college for the first semester, you learn Python 1, Python 2, Python 3, whatever, right? This different course, we call it computer programming, right? So computer programming's main purpose is that you learn the language, you learn the object-oriented programming idea, you learn the so-called sorting, you learn the so-called data structure, okay, that's it. You use that for programming. And here we talk about pragmatics. It's a mechanism of the programming language. How you design a programming language, how you make it work, how you can use that interpreter in the software development, right? That's the goal. That's the goal. So the term project, you see, I told you, you have a search engine, you get a text, you get a text input over here, right? You kind of translate it in some sort of knowledge net. Okay, that's good. AI knowledge net. You do learning, that's good. Okay, whatever you want to do, you just do it. Eventually, you will deliver some sort of product, data product for people. That's the sort of mechanism we are trying to teach this time. Is that okay? That is the mechanism we want to teach this time. It's different from compiler. Okay, so in the old day, this programming language actually only serving for compiler and interpreter. But that's the narrow sense of the language interpretation. The language interpretation now is actually much broader, including natural language processing. You input English, return Spanish, input English, return Chinese, language processing. Is that okay? So this mechanism right now is very popular and is actually is a core for data science, core for AI right now. We want you to have such a view on the software. We don't want you to just say, okay, CS is supposed to be working on programming. Okay, that's it. Other things, I don't know. Don't ask me. You give me the product description, I will work out the code for you. Okay, that's traditional view of CS. No, it's not that way now. Okay, computer science right now is a problem solver. You need to retrieve some information from internet. Just go ahead, just do it. Okay, you need to translate language. Just do it. That's computational linguistic. You need to build AI system. Just use it. Okay. You need to have auto response system. Let's do it. Let's actually use our programming knowledge, programming language knowledge to do it. Okay? Is that okay?
Yes, that sounds great.
So it's actually going beyond just coding. Okay, going beyond just coding. And that's what we want to teach you, the so-called programming language course here. Okay. You guys are lucky. This actually is the very first semester I use the new material. Okay, the previous I teach here for 4 or 5 years. Okay, you can see that I actually do teach many years before. Okay, 5 years before. Okay, so this is my 6th year to stay with Louis right now. Okay, I teach 5 years of the same old material before, and they just teach you some older language. Okay, is that okay? It just teaches you some older language. So you can refer to the previous year's video. But this year we do have a big change. We focus our goal, okay? No longer make it a traditional old-fashioned programming language course. Some students do have the impression that this course is what? Usually this course, we just need this course for graduation. right? I do see some students post in their discussion session saying that, okay, why am I taking this course? I'm taking this course just because that it is on the requirement. You know what I'm saying? Some students just say that. Okay, that's actually very true that a lot of students have that impression. But let's do it in different ways since we need to do it, right? So why don't we try to have a new attitude towards course? Let's put this course into use. Is that okay? That's the purpose of me trying to revive the whole curriculum for this course. Okay.
That sounds good because I feel like I have taken a course or two that shouldn't. I like they had at COD. I'm a COD student, and we had like Microsoft Access, and I felt like instead of having Microsoft Access, we should have just had SQL because Microsoft Access, I'm sure, is being used in the real world, but when you get into computer science and programming, I'm sure SQL, that database system, would have been a better benefit as a course for us. So I thank you that you are taking the class and like challenging us.
Mm-hmm. Yeah, actually, sometimes, I mean, you say, for example, you learn some language like C#, right? F#. You can only work for Microsoft. Other company doesn't use it, right? You know what I'm saying? So here in the university, we try to teach you more core knowledge. And you go to Amazon, you need to Amazon Web Service, right? You go to Google, you need to program in Google Cloud, Google API, right? So in a way, nowadays the company and the university do teach different things, okay? Do use different things. We cannot teach you AWS, okay? We are not vocational school. We don't teach you just for the job preparation. We do need to teach you some core knowledge, okay? Core knowledge. So you come to university to learn the core knowledge, to prepare yourself to be able to handle some core knowledge, okay? And we actually, if you look at the syllabus that I have, okay, the syllabus that I have, I do suggest you a certain path, okay, a certain path in the syllabus. Okay, so here, these are the computer science, what computer science students are supposed to learn, okay, supposed to learn. That's the core knowledge you are supposed to learn, including hardware track, okay? So some students don't like hardware, okay, it's okay. Just don't take it, okay? If you don't like hardware, you don't take this hardware track, okay? And this one is theory track, okay? Theory track, if you don't like it, okay, don't take it, okay, don't take it. But at least this linear algebra, Boolean algebra, and discrete math, these are the minimum math you need to take. Other than that, this programming, at least you need to go to here, okay? So this portion and maybe up to here, this portion, these are the core knowledge every computer scientist need to have. Is that okay? Need to have before your graduation. And more than that, you may take computer architecting, take networking, take database, take whatever. Okay, that's not a core. You is welcome to add more knowledge to it. Okay, but here you must learn Python 1, 2, data structure algorithm, programming, at least up to here, minimum. Okay, minimum. Is that okay? Before you graduate from college. Any more questions? Monica, are you okay?
Yeah, I'm fine. Thank you.
Okay. So usually, okay, this is a chart. This is a chart I show for different students. If they come to computer science, ask me for the advisement of how to get started, I actually do that. And in the same time, I also, for example, my own son, I do actually set up the 4-year study plan, okay, depending on the university I go to. This is one of my son in Berkeley, okay, his schedule. Okay, I have another son graduate from UC Irvine, so I also have the UC Irvine's schedule. So before he started 4 year, I do plan for him about what are the minimum course you need to have and how you are going to spend your 4 year in university. Okay, and for him, for this my elder son, he spent time in. Okay, let's see. He's schedule. Okay, let me see. Not here. Okay, not this one. Graduation housing. Okay, UCI courses. Okay, here. Okay, he actually he has a different version. Okay, so toward his graduation, he took 238 quarter unit. Okay, but usually it's only 180 required. So over here, I want him to take basic Python 1, Python 2, Python 3. Okay, but he has ABCSA, so he skip Python 1, Python 2. Skip Python 1. He starts Python 2, Python 3. Okay, and then he took C double plus OOP. Okay. Take C double plus data structure, take Java 2, Java 3, okay, and then information retrieval that I mentioned about, okay, and then programming language 141, okay, 141, and take database, okay, take computer network, take algorithm, take system programming, take computer architecture, right? And he add statistics minor, so statistics minor are all in green color. For data science, okay, statistics, okay, these are for statistics minors, even in summer. Okay, red one are AI, okay, so red one in the last year, he actually strongly emphasized on AI, so including introduction to AI, okay, and probability for computer science, this is also for AI, machine learning, okay, next generation searching, also AI project, okay, is that okay? Now that's how he spent his 4 year. First 2 year course, yes. Third year stats minor and courses, core courses for CS. Last year strongly emphasized on AI. Okay. Is that okay? Try to plan your schedule so that is actually you can get enough knowledge for your career. Okay. Okay, can we stop here? Hello.
Yes, thank you so
Okay,
much.
okay. See you next week, okay? See you. Bye-bye.
Take care, everybody.
Thank you.
Bye-bye.